The first thing we're going to do here is construct the truth table for the proposition P implies Q. So this down here is P implies Q, or if P then Q. Okay, what we have to do there is construct the truth table for that. Straightforward enough, usual truth table construction. So we'll start off with P and Q, and we'll put out the usual pattern of ones and zeros, trues and falses. So P and Q first off, we'll start from the right hand side and move left. 0, 0, sorry, 0, 1, 0, 1. Now 0, 0, 1 and 1. Let's just make those lines a little bit longer. So now we're going to put in P implies Q. Now this, for I've done a different presentation where I sort of like put more explanation into where these values come from, but for this part here, what we're going to do is just I'm just going to sort of say it's one to sort of memorize P or Q, P and Q, and P implies Q. I recommend having them, this sort of thing, memorized as well as being able to rationalize it or discuss it. So it's 1101. Okay. Now, let n be the element of the set 1 to 7. So the numbers there 1 to 7. And let P, Q be the proposition as follows. P, n is even, and Q, n is greater than 4. So what we're going to do now is write out that truth table there. And I'm going to set it up here. N, 1, 2, 3, 4, 5, 6, and 7. Now, what we're going to do next is see, are these values true for P and are they true for Q? So, again, we set up a little truth table here like this, very similar to what I've done the last time. And what will be helpful for us in the first instance is to go through the data set, or through the values, and just tick them off one by one. So the value, we'll do P first, and that P is n is even. Well, that's not even, so we're going to put a 0 there, that's false. 2 is even, that's true, so put that at 1. 0, 1, 0, 1, and 0. Okay, so alternating between zeros and ones. The next one is Q, n is greater than 4. So 1 is not greater than 4, 2 is not greater than 4, 3 is not greater than 4. Watch out for this one. N is greater than 4. 4 isn't greater than 4. So that's a 0 there. 1, 1, and 1. Lastly, what we're going to do now is write the values for n for which P implies Q is equal to true. So this is the point of having the table as we have it over there on the left hand side. We'll be able to sort of detect quickly what values we need by using this table. And what we're going to do is look at this pairing here and see what we need over here. So 0 and 0, that gives us a 1. Let's do that one there. That's a 3 also gives us a 1. And that's it. 0 and 1 will give us a 1. So there's none of those. Okay. Ones and zeros, that will give us a 0. So a 0 here and a 0 here. Sorry, there's a 0 and a 1 there. So that will give us a 1. That will give us a 1 as well. And finally, 1 and 1, there we have it there. So the values are 1, 3, 5, 6, and 7. Those are the values that we have to pick out. Those are the values for which the P implies Q is true. Okay, so that's that part done.